Good morning, everyone. This is Miss Xiao. Today, I am going to do a little sharing about a math topic with you, suitable for primary 3 students. And for primary 4 and 5 students out there, if you find that you will want to learn along, feel free to click on the video and learn together. Who knows, this might be an opportunity for you to review through what you have learned or affirm what you have learned. Now let's go ahead with the lesson. Today, the topic that I will be covering is tackling primary 3 fractions. Okay. Now, fractions is something that starts off as a small topic in primary 2, and it moves on to a slightly bigger topic in primary 3, and subsequently, primary 4 is going to get quite tough. So let's take a look and review through some of the questions that you will come across in primary 3 fractions. Okay, so let's take a look at a question here. This is taken from MGS, Primary 3 SA2 2019 paper. It says that Nora ate half of a chocolate cake. Janet ate 3/12 of the same cake. What fraction of the cake did they eat all together? What fraction of the cake was left? Give both answers in the simplest form. Now, just looking at the question, okay, you can imagine that there is one chocolate cake. Okay? First sentence says that it is half of a chocolate cake. Second sentence mentions that Janet ate 3 out of 12 of the same cake. So we're not talking about two different cakes, but two portions, in fact, of the same cake. So to answer question A, what fraction of the cake did they eat all together? Now the words they and the words all together give us a hint that we have to add the portion that Nora had eaten to the portion that Janet had eaten. So we know that Nora had eaten half of the cake and Janet has eaten 3 out of 12 of the cake. So if we were to find the portion eaten altogether, it will be half added to 3 out of 12. Now, how would we add two fractions together? We will have to make sure that our denominators are the same before we can add them together. Okay. Now, how do we change both denominators to make it the same? If you take note, the first denominator is 2 and the second denominator is 12. What we can do is, if we were to look at the first fraction, which is half, we ask ourselves whether we could find an equivalent fraction to half to make the denominator become 12. And you will find that yes, we can by simply taking half and we multiply the numerator and the denominator by 6. Okay, so 1 times 6 in the numerator makes 6 and 2 times 6 in the denominator makes 12. So half is also written as 6 out of 12. So I'm going to put it on the second line. Now, I can combine both fractions together, knowing that the denominators of both fractions are the same. So 6 out of 12 pieces add to 3 out of 12 pieces, we actually end up with 9 out of 12 pieces. Okay, now would this be the final answer? We have to ask ourselves whether this is in the simplest form or not. Now, whether or not a fraction is in the simplest form depends on whether we can divide both numerator and denominator by the same number. So if you were to look at numerator and denominator, numerator is 9. 9 can be divided by 3. Now, and we ask ourselves, can we also divide 12 by the same number 3? Answer is yes, right? Yeah, so when we divide both numerator and denominator by 3, what we will end up with is 3 out of 4. And we ask ourselves again, is there any number that we can divide 3 and 4 by to further reduce this fraction? And you realize that there isn't. So this is the answer in the simplest form. Okay, so that's the answer for A. Now we'll move on to the question B. What fraction of the cake was left? Now we know that there is one cake, right? And this cake is either being eaten up. In this case, it was eaten by Nora and Janet. And whatever that is left has not been eaten. So I'm just putting it down in this summary that one cake is split into the portion that has been eaten and the portion that has not been eaten. So now we know from part A that 3/4 of the cake has been eaten. Could we find out the fraction of the cake that was left being not eaten? So since the entire cake makes up one whole, and we know that 3/4 of this one whole of a cake has been eaten, whatever that is left is one whole. Take away whatever that was eaten. Okay. So, oops, we have a problem here. The problem is that one whole has got no denominator. How do we do that? Now, what we could do is we could convert one whole into a fraction. One whole could be written as 1 out of 1. It can be written as 2 out of 2, 3 out of 3, so on and so forth. Now, what we want to change this one whole into is to change it into a fraction whereby the denominator of that fraction is the same as 3/4. So it's most suitable to change one whole into 4 out of 4. So 4 out of 4 minus 3 out of 4, we will get 1 out of 4. So that's the answer for P. Now let's take a look at the next question. Next question is taken from Pei Hwa Presbyterian Primary School, P4 Weighted Assessment 2019. It says that the sum of two fractions is 9 out of 10. The difference between the two fractions is half. What are the two fractions? Okay, so let's see. If the sum of two fractions is 9 out of 10, we can write down something like that. Something out of 10 plus something out of 10 gives you 9 out of 10, right? Okay, maybe for the first fraction, let me put 2 question marks there. Then we can differentiate the first from the second fraction. The difference between the two fractions is half. So first fraction minus the second fraction gives you half. What are the two fractions? Now, first and foremost, what I can notice very glaringly from here is that the denominators, again, the denominators of both fractions are different. Perhaps to simplify the question, what we could do is we could convert a half into another fraction that has the same denominator as 9 out of 10. And we will know that half is actually 5 out of 10 when we multiply both numerator and denominator by 5. Okay, so now let's see what fractions we could come up with such that when one subtracts the other, you get 5 out of 10, such that one adds to the other, you get 9 out of 10. This seems to be a play of number bonds, trying to see whether you are able to list down the various number bonds whereby they add up to be 9 or they subtract to be 5. Okay, so let's take a look at the possible answers. So if the first numerator, the numerator of the first fraction, okay, is say 10. we can't possibly work out anything that amounts to the second fraction. So 10 is definitely out. Okay, so how about 9? If the first fraction, numerator is 9, okay, 9 plus 0 will give you, yes, a numerator of 9, but 9 minus 0 does not give you a numerator of 5. Okay, so this combination of 9 and 0 is out. So let's try 8. If it's 8 plus 1, that gives you 9, okay. However, 8 subtract 1, does it give you 5? No, again, it does not. So this list does not work. How about 7? 7 plus 2, that gives you 9. 7 subtract 2, that gives you 5. Hey, this works. Yeah? So let's try to put 7 and 2 into the equation again, okay, on the left. So what will happen is that in place of question mark plus 10, it will be 7 out of 10 plus 2 out of 10. And this, yes, this gives us 9 out of 10. And if we were to have 7 out of 10, subtract 2 out of 10, we get 5 out of 10, and we bring it down to the simplest form, getting half. So what are our two fractions here? Two fractions are 9 out of 10 and half. So this is quite a tough question, but it's worth going into, right? Yeah. Now let's move on to the next one. This is taken from Red Swastika School, Primary 3, SA2 2018 paper. Now, Pamela cut a pizza into 8 pieces. She gave 5 pieces to her friends and ate 1/8 of the pizza. What fraction of the pizza had she left? So if she were to have a pizza, you could imagine this is what she has, and she's going to cut it into 8 pieces. So if there are 8 pieces, our denominator will be 8. Question says she gave 5 pieces to her friends. So 1, 2, 3, 4, 5, meaning 5 out of 8 were given. Apart from that, she ate 1/8 of the pizza. So this was what she ate. Yep. So this is either given or eaten. So what fraction of the pizza had she left? Okay, whatever that I have not shaded is actually what is left. So we see 2 out of 8 parts of the pizza that is not eaten. And we ask ourselves, is this in the simplest form? Well, 2 and 8 can both be divided by 2 to bring it to the simplest form. So that gives us an answer of 1/4. Now we're going to move on to the last question. I know this is not exactly a word problem, but it's very, very commonly tested for Primary 3. It's also taken from Red Swastika School, Primary 3, SA2 2018 paper. Okay, now arrange the fractions in order, beginning with the greatest. Numerators are different, it's hard to compare. Denominators are also different, it's hard to compare. Well, we have to try to make either the numerators become the same or the denominators become the same before we can make good comparisons. Yeah, so let's take a look at the denominator. Denominator has 3, 4, and 12. Let's see whether we have a relationship between the numbers here. Can our denominator 3 become 12 by finding some sort of an equivalent fraction? Now, if we want to explore 2 out of 3, okay, you realize that 2 out of 3 can indeed be an equivalent fraction of denominator 12. Yeah, we can multiply the both numerator and denominator by 4. So we have 8 out of 12. Now, how about 1/4? 1/4 can also be changed into an equivalent fraction with denominator 12. How do we do that? We multiply denominator 4 by 3, and we also multiply numerator 1, I'm sorry, by 3. And that leaves us with 3 out of 12. Okay, so now let me use another color. Okay, now we have 2/3 being also known as 8 out of 12. 1/4 also known as 3 out of 12. And 5/12 remains as 5/12. Could we easily arrange them in order of beginning with the greatest now? Greatest would mean that the numerator is greatest, right? Yes. So this comes first, 8 out of 12, followed by 5 out of 12 parts, and 3 out of 12 parts. How do we display the answer? Now you might be wondering, do I write the, the fraction, equivalent fraction that I've come up with, 8/12, 3/12, 5/12, or do I express it in the original fraction given? What are your thoughts? Now, when you derive the equivalent fraction, what you are doing is just you're part of the working to justify which comes first, which is bigger, which is smaller. But when you come to the ordering of it and presenting your answer, always go back to the original fractions given to you. So instead of putting down 8/12 as the first answer, you have to write down 2/3, followed by 5/12, and ending up with 1/4. So this will be the answer. If you were to write your answer as 8/12, 5/12, and 3/12, I'm afraid you will not get the marks. Yes, you got the idea, you got the concept, but the marks will not be given to you because you did not arrange the fractions given to you in order. You arranged your own equivalent fractions. Yeah, so just take note of this. I hope that going through these questions can actually help you understand fractions a little bit more. I know it can be daunting at times when we come across fractions because it's so different from whole numbers that you've been so used to for P1, P2, and P3. And well, hopefully this will give you some understanding and confidence, more importantly, as you meet with the SA2. So all the best, everyone. Stay safe, stay healthy, and love maths. Goodbye.